In this video, I will show you how to prove that two triangles are congruent. So we're given what is marked, and in addition to what's marked, we can always know that a shared side will be congruent for both triangles. So we can mark that as well. Now, unfortunately, we cannot prove that the triangles are congruent because this would be side-side angle, and side-side angle does not prove that triangles are congruent. So make sure you leave all this up here blank. So looking at problem number 2, we're given that segment AD and BE bisect each other. That means that they cut each other in half. So that means that AC will be congruent to CD and BC will be congruent to CE. In addition to that, we can know that the vertical angles here are also congruent. That makes the two triangles congruent by side, angle, side, because you can see we have two sides and the angle that's between them. So we can go ahead and say that triangle ABC is congruent to triangle, let's see, if it went ABC, then we have to do DEC. So congruent to triangle DEC. All right, for number 3, segment BC bisects angle ACD and ABD. So it bisects both sides. So we're going to have two congruent parts on the right-hand side, and we will have two congruent angles on the left as well. And the shared side will also be congruent, so we can mark that. So these two triangles will be congruent by angle, side, angle. So we can say that triangle ABC is congruent to triangle DBC. Okay, we are given that AD is perpendicular to CB. Perpendicular means that it forms a right angle, so we can go ahead and mark that. And also the shared side will be automatically congruent. So that means that we have an angle, angle, side situation. So these triangles will be congruent by angle, angle, side. Triangle ABC is congruent to triangle DBC. Alright, if we want to prove that these triangles are congruent by angle, side, angle, what additional piece of information would have to be given? So we've got an angle and a side, so we're going to need another angle. Alright, and the side has to be between the two angles. So if we have this angle right here, that would be angle, side, angle. So we'd have to be given that angle L is congruent to angle U. Alright, so that's B. Number 6, if we want to prove that these triangles are congruent by angle, angle, side, what additional piece of information would have to be given? For angle, angle, side, we want the side to not be between the two angles. So I would have to put the additional angle over here. That way the side is not between them. That's what makes it angle, angle, side. So in the other triangle, I will have to put it over here so that the side is not in the middle of the two angles. So that means angle D would have to be congruent to angle H. So that is C. If we want to prove these triangles congruent by side, angle, side, what additional piece of information would have to be given? So we have a side and an angle, so we need another side. And remember, for side, angle, side, the angle has to be between the two sides. So it has to be this side. And on this picture, I would need this side, because that puts the angle between the two sides. So that means CD would have to be congruent to GH. Okay, so that's B. All right, looking at number 8. If we know that triangle GEO is congruent to triangle FUN, which of the following must be true? Circle all that apply. Okay, let's see what we have. Is GO congruent to FN? All right, just going by the positions, G and O, that's the beginning and the end, corresponds to F and N. So these will definitely be congruent. Okay, what about OE? OE will be congruent to UN, not UF. So we won't circle that one. Okay, what about angle E? Angle E is congruent to angle U. Okay, so that's true, so we will circle that one. Okay. Now, what about triangle EGO? All right, will that be congruent to triangle NUF? Let's see. E maps onto U. So right there, it fails immediately, right? E corresponds with U. So if you put E first, then U should be first. And it's not, so we won't circle that one. We'll leave that one blank. All right, looking at problem number 9. In this diagram, we are given that segment BC is parallel to segment AE. Which of the following must be true? So whenever they mention parallel segments, you should trace them. So BC is parallel to AE. So for one thing, if we draw this line going across them, it forms kind of a sideways F. These are corresponding angles. So we know that these angles in the corner will be congruent. So that is angle CBA, all right, which I see right here, and angle EAD, which I see right here. All right, so this is definitely going to be true. Okay. Now, that's the only information that we have. We don't know that A is the midpoint or anything else, all right? So we can't prove that the triangles are congruent. So we just can't conclude anything else. Yeah, this is the only thing that we know. So based on the parallel lines, these angles will be congruent, and that's it. We'll circle this, leave everything else blank. For number 10, we are given that angle D is congruent to angle C. So let's mark that. We are also given that segment BA bisects angle DAC. All right, so be careful. So we're bisecting angle DAC. So DAC is this angle out here. So if we're bisecting this yellow angle, that means we're splitting it in half. So that means these two smaller angles will be congruent. All right, so that's it for the given. So we ask ourselves, is there anything else that we can mark? Well, the shared side will always be congruent, so we can mark that as well. Oh yeah, I need to fill this in. So because of the bisecting, we had the angle DAB is going to be congruent to angle CAB. All right, those are the two little angles right here. The reflexive property tells us that segment BA is congruent to segment BA. So, therefore, these triangles are congruent by angle, angle, side. Notice the side is not between the angles, so it is angle, angle, side. And matching up the letters in the proper order. If we go A, B, C, the other triangle will be A, B, D. Okay, number 11. C and D are right angles. Okay, so here's C and here's D. So that means that angle C is congruent to angle D. All right, real simple. We also know that A is the midpoint of CD. So if A is the midpoint, that means CA will be congruent to AD. Segment CA will be congruent to segment vertical angles are congruent, so angle BAC is congruent to angle EAD. All right, notice you cannot simply say angle A is congruent to angle A. You have to use the three-letter name. So that means the triangles are congruent by angle, side, angle. So let's see, triangle ABC is congruent to triangle. So ABC, AED. Okay, ABCD is a parallelogram, that's given. All right, now, segment AB is congruent to segment CD. That's because opposite sides of a parallelogram are congruent. Now, that's one of the properties of a parallelogram, but we should go ahead and spell it out like this. Opposite sides of a parallelogram are congruent. So, similarly, segment DA will be congruent to segment BC for the same exact reason. All right, but then, of course, segment AC will be congruent to segment AC because of the reflexive property. All right, and now we can go ahead and say that the two triangles are congruent by side, side, side. Number 13, we are given that C is the midpoint of BD. And we are given that C is the midpoint of segment EA. So might as well get that out of the way. So those are both given. All right, so that's the end of the given. But those two facts lead to two more facts. Because C is the midpoint of BD, that means that segment BC is congruent to segment CD. Because C is the midpoint of EA, that means that segment EC will be congruent to segment CA. So segment EC will be congruent to segment CA. The reason for both of those will be the same. That's the definition of midpoint. Definition of midpoint. Okay, if you look diagonally to the previous statement, it will give you a hint for what the reason will be. C is the midpoint of EA, definition of midpoint, those match. All right, if this had said bisector, we'd be talking about definition of bisector right now. Okay, so what else? We've used up the given, but I'm noticing that we have vertical angles here, so we can always mark those as congruent. So that was angle ECD, which will be congruent to angle ACB. And those are vertical angles, so the reason is just vertical angles are congruent. All right, now that's enough information to say that the two triangles are congruent. So we can go ahead and say triangle ABC is congruent to triangle EDC. And this will be side angle side. Okay, number 14. Angle A and D are right angles. So we can put the little boxes in. All right, whenever we mention that two angles are right angles, the next statement will be that those same two angles are congruent. And the reason is because right angles are congruent. And then here comes our next given. Segment AB is parallel to segment CD. So that leads directly to congruent angles. And here's how. Start by tracing the parallel segments. So segment AB is parallel to segment CD, so trace those. And then make a Z out of it. So once you do that, it's easy to see that the corners of the Z will be congruent. And that's because these are alternate interior angles. So this is so the reason will be the alternate interior angles theorem. So alternate interior angles theorem. Okay, so that uses up the given. So we look for other things we can mark just based on the picture. And we see the shared side, we can always mark that as congruent. But what we put in the proof here is that segment CB is congruent to segment CB. And the reason will be the reflexive property. So, looking at the picture, we now have enough information to prove that these two triangles are congruent. Which one of the five properties will prove that these two triangles are congruent? Well, let's see. We have two angles and a side that's not between them. So these triangles are congruent by angle, angle, side. So sometimes that's the end of the proof. Very often we are being asked to prove that the triangles are congruent. So when we get to this step, we're done. But in this case, we were not actually being asked to prove that the triangles were congruent. We needed to do that in order to prove that segment AC is congruent to segment DB. But this is actually an extra step after proving that the triangles are congruent. So what's the reason that we always use to justify why two parts are congruent after we've already proven that the triangles themselves are congruent? Hopefully you're thinking CPCTC. That stands for corresponding parts of congruent triangles are congruent. Okay, let's take a look at number 15. Okay, so we have AC congruent to EC. Those are already marked. Angle E is congruent to angle A. That's marked as well. Okay. We also know that the vertical angles will be congruent, so we can mark those as well. That's enough information to prove that the triangles are congruent by angle, side, angle. Okay, so now we need to use some algebra and find these numbers. So for angle E, well, we know that angle E is congruent to angle A. Angle A is 48. So that means angle E is also 48. Okay, what about angle ACB? All right, angle ACB is one of the vertical angles here. Okay, so I feel like I need to zoom in. All right, let's fill in some additional information. Angle A is 48, so that means this is 48 right here. Angle B is 46, so that means this is going to be 46 right here. Okay, now these two triangles are going to be congruent. Notice that A and E are congruent, so that means this is going to be 48 right here. That means angle B corresponds with angle D, so that's going to be 46 right here. Now, what about these vertical angles? I feel like I should move this now. Well, let's subtract from 180, and that will tell us what this missing angle is. Let's ask Siri. Hey Siri, 180 minus 46 minus 48.
180 minus 46 minus 48 is 86.
So this missing angle is going to be 86. All right, so both of these are 86. Okay, so now we should be able to answer anything. So let's see. Angle ACB is this 86 degree, it's one of the vertical angles, so that's going to be 86 degrees. Okay, now what about CE? All right, so CE is congruent to AC. and AC is 15. So that means CE must also be 15. All right, CD is congruent with BC. It's not marked congruent, but I know that these are corresponding sides, just the way they match up. Okay, I don't even really need the picture. I know that CD is, see how that's the last two letters, and BC is the last two letters? So those match up. So BC is the same as CD. So I know that this will be 12. All right, so for number 16, we're given some facts here, and we know that triangle ABC is congruent to triangle DEF. So we'll come back to that. First, we are being asked to find x. Okay, so let's see what I can do. I have angle A. So see how angle A is first? Angle A corresponds with angle D. So that is not going to help me. All right, because I don't have an expression for angle D. So I'll come back to that. Let me erase that. All right, so I'm going to move on to angle B for a minute. So see how angle B is second? Angle B corresponds with angle E. And I do have an expression for both of those. So angle B and angle E should both be congruent. So that means that 6x minus 12 should equal 4x plus 8. So subtracting 4x from both sides, that will give me 2x minus 12 is equal to 8. And if I add 12 to both sides, that will give me 2x is equal to 20. And if I divide both sides by 2, I get x is equal to 10. All right, so x is 10. Then I need to find the measure of angle A. So I do have an expression for that. So the measure of angle A is 2x plus 16. But now I know that x is 10, so this will be 2 times 10 plus 16. So that's going to be 20 plus 16, so that'll be 36. I also need to find the measure of angle B. And the measure of angle B is 6x minus 12. So that means that the measure of angle B is going to be 6 times 10 minus 12. So that should be 60 minus 12. So that's going to be 48. And then finally, we're asked to find the measure of angle C. But triangle ABC is one triangle. All right, so it mentions triangle ABC right here. So that means that A, B, and C all have to add up to 180. So if I just take 180 and I subtract the 36 and the 48, that should give me the remaining angle C. Hey Siri, 180 minus 36 minus 48.
180 minus 36 minus 48 is 96.
So angle C should be 96 degrees. Okay, so we have a review question here. So when you have a parallelogram, consecutive angles like these should be supplementary. They're not congruent, so don't just set these equal to each other, but it should be like this. Let's see, 5x plus 10 plus 3x plus 34. These should add up to 180. Okay, so combining like terms, that'll be 8x plus 44 is equal to 180. And then if we subtract 44 from both sides, so that's going to be 136. And then if we divide that by 8, that gives us x is equal to 17. Okay, here's a random bonus question. Let's see what we can do with it. Well, we have a couple of triangles, so let's go ahead and draw them. Okay, so we have triangle CAT, and that is congruent to triangle DOG. Okay, what else? So we have expressions for the measure of angle A. You know what, maybe I'll squeeze these in here. So A is 4x minus 2. So I'll have 4x minus 2. And angle C is 8x plus 2. And D is 3y plus 7. And G is 6x plus 27. All right, ultimately we're supposed to find the value of x and y. Okay, what can we do? Here's something I think would be fun. Angle T and angle G are corresponding angles, so they should be congruent. That means if angle G can be represented by the expression 6x plus 27, then angle T should be the same thing. All right, they're congruent. So I should be able to go ahead and put a 6x plus 27 right here. Similarly, if I wanted to, A and O are the same, so I could put a 4x minus 2 right there. Now, one of these triangles only has one variable in it. Do you see what I'm talking about? Triangle CAT only has x in it. So we should be able to solve this thing, shouldn't we? Because the sum of the angles in a triangle is 180 degrees. So if I add all of these up, in other words, if I go 8x plus 2 plus 6x plus 27 plus 4x minus 2, all of that should add up to 180. Let's see, 6 and 4 is 10, plus 8 is 18. So I've got 18x. I see a positive 2 and a negative 2, so those cancel each other out. And then I've got the 27. So that equals 180. So if I subtract 27 from both sides, I get 153. So next it would be time to divide both sides by 18. So just in my calculator, I'm doing 153 divided by 18, and that is 8.5. Okay, so I'm getting that x is 8.5. All right, so now I just need to find y. Well, y is right here in this expression. I feel like changing colors for a second. So you see how angle C corresponds with angle D. So these two should be equal to each other. So in other words, 8x plus 2 should equal 3y plus 7. Okay, but now I know that x is 8.5. So that means I have 8 times 8.5 plus 2 is equal to 3y plus 7. So in my calculator, I'm doing 8 times 8.5. That's 68. Uh, 68 plus 2 is 70. If I subtract 7 from both sides, that's going to make 63. And then if I divide both sides by 3, that's going to make 21. So there you go. X is 8.5 and y is 21. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.